Alright guys, this lesson is on factoring polynomials. We're going to go ahead and get started. This is actually going to be several lessons in one. We're looking at greatest common factor, factoring trinomials, trinomials where there's a coefficient in front. We're looking at some special products, and then with four terms. Okay, we're just going to look at the greatest common factor and trinomial factoring today. Okay, all right. So in order to kind of get into factoring polynomials, we need to first review what factoring is, or what finding the greatest common factor is. So here in example one, if I'm going to factor something, I'm going to look to see what I can pull out of the entire, in this case it's a binomial because there's two terms. So what can I pull out of both terms? Well, I can pull out just a 2 out of both of those. Okay, so if I'm going to divide a 2 out, I'm going to leave it on the outside of the parentheses, and then what's left in the binomial? Well, 2 divided by 2 is just 1, so I'm left with x. And then plus, well, 42 divided by 2 is 21, and then y is also left. Okay, so that's just factoring numbers out. And that's that greatest common factor, okay? So example 2, what can I pull out? Well, I can pull out a 4, but I can also pull out some x's. My my lowest exponent is a 3. I can't pull out any more than 3 x's, but there is going to be 3 there, and there's going to be 3 here. So I'm able to divide out the 4, and I'm also able to divide out an x to the third power. Okay, so that's what I pulled out, 4x cubed. And then my binomial has, well, 4 divided by 4 is 1. And here's my quotient rule. Subtract your exponents. 4 minus 3 is 1. So there's just 1x there, plus 24 divided by 4 is 6. And 3 minus 3 is 0. There's nothing left. There's no x's left on that second part of the term. Okay. Example 3. Okay, again, pulling out the biggest thing that I can. From my coefficients, I'm going to be able to pull out a 2. And then I've got an a and a b. The smallest exponent I have for a is a 1, so I can only pull out one a. And then b, there's 1 here and 2 there. I can't pull out any more than 1 because there's nothing to pull away from. Okay. So 2ab, and then what's left? 8 divided by 2 is 4. A squared divided by a is just 1a, and there's no b's left. Minus, there's my minus sign. 6 divided by 2 is 3. A of 1 and a to the first, they divide out, and then I'm left with b to the first. My quotient rule is to subtract those exponents. Okay, so there's one b there. Okay. Example 4. See what we can divide out. Let's see, I can pull a 5 out of 20, but I can't pull a 5 out of that. So I'm going to be able to pull a 4 out of both of those. And what variable? Well, definitely an x and a y, but how many? There's only one of each there, so I can't pull out any more than one of each. Okay, and what's left? 20 divided by 4 is 5. X squared divided by x is just 1x. Y squared divided by y is just 1y. Minus 4 divided by 4 is 1. X divided by x is just 1. Everything is just 1. Okay. Good. All right, so to summarize with pulling out those greatest common factors, we want to, whoops. So anyway, we're going to divide out the greatest common factor. Okay, that's going to include the coefficient and variables. And leave the GCF on the outside of parentheses. Oh. Okay. Okay, so that is greatest common factor. So now with trinomial factoring, okay, it's going to get a little bit more in depth. So this is what it looks like when I multiply two binomials together. Okay. Now I know that with a binomial, I used FOIL. So first, inner, outer, last. Well, in order to get these middle terms, there were two terms that combined that added to get an 11x. So there's going to be one that added to 11. I need to find out what added to 11. And then it had to multiply to get to 18. Okay, anyway. So I need to find two numbers that are going to multiply to give me 18 and add to give me 11. Okay, so I know that factors of 18, so 1 times 18, well, that gives me 19, so that's not going to work. I also have 2 times 9, which will give me 11. Ooh, so that works. What is another factor? We have 3 times 6. 3 plus 6 adds to 9. Okay, so this is what I'm going to need to use as my factor. Okay, so I have then x, and there's a positive 2 and a positive of 9. So x plus 2 is one binomial, and then x plus 9 is my other. And if I multiply those two binomials together, it's going to factor out to give me that. Okay? And you can check it if you'd like. All right, so example 6. Okay, I'm going to have to find something that multiplies to give me 14, and it also has to add to give me 9. Okay, that multiplies to 14 and also adds to 9. Well, factors of 14, 1 times 14, but that gives me 15 when I add 1 and 14 together. Okay, there's 2 times 7, and 2 plus 7 is 9. So that's my perfect factor there. So it's going to be m, because that's my variable, plus 2 times m plus 7. Okay? Example 7. We need to multiply to give me 8 and add to give me negative 6. Okay? So we have 1 times 8, but that gives me 9. 2 times 4, add them together, it gives me 6. Negative 1 times negative 8 gives me negative 9. Okay, when that's multiplied them together, it gives me 8, but it adds to only give me 9. And then negative 2 times negative 4 will give me a positive 8, and it'll also give me, if I added them, a negative 6. Okay? So that's what I'm going to use. I'm going to say y, and they're negatives, minus 2, and then times y minus 4. So multiplying those two binomials together will give me that. So this is called factoring it out. Okay? All right, so number 8. we're going to have to multiply to negative 15 and add to give me a positive 2. Okay, so I have 1 times negative 15, but that only gives me negative 14 if I add them. Okay, negative 1 times 15, but that gives me positive 14. That doesn't give me negative 2. 3 times negative 5 gives me negative 2. So if I did negative 3 times 5, it'll give me positive 2 when I add them together. Okay, so that's perfect. Both of those numbers multiply to 15, and if I added them, they give me positive 2. So where's my binomial is a negative 3, w minus 3 times w plus 5. Okay? Now let's summarize. Okay? We're going to set up a table to determine factors that, getting ahead of myself, that add and multiply to the expression. Okay? All right, so the code word for that, we're going to stop there for today. The code word for this lesson is flowers. Okay. If you have questions, you can feel free to email me. Do not forget to do your left-hand page. And yep, that's it. Okay.